The melting point of a pure compound is a characteristic physical property, meaning that it remains constant under specific conditions. When impurities are present in a substance, they can cause a depression or broadening of the melting point range. In general, a higher melting point indicates a higher degree of purity. Pure substances typically have a sharp and narrow melting point range, whereas impurities can cause the melting point to decrease and become broader. This is because impurities disrupt the regular arrangement and bonding between the molecules or ions in the substance, making it more difficult for the compound to form a solid lattice. When the crystal lattice containing impurities is melted, the presence of impurities can alter the melting behavior compared to a pure crystal lattice. In summary, the melting point of a substance is directly related to its purity. A higher melting point and a narrow melting point range indicate a higher degree of purity, while impurities cause a depression in the melting point and broaden its range. The relationship between melting point and purity is essential in chemical analysis, quality control, and the identification of substances. The graph below shows how the temperature changes with time as a substance is heated at a constant rate. There are obvious horizontal flat sections of the graph at the melting and boiling point called plateau. Below the melting point the substance is a solid. Above the melting point the substance is a liquid. At the melting point, although the substance is still being heated, there is a time when the temperature does not change, remains constant, and the graph is horizontal. During this time, all the extra heat which is being added goes to overcome the force of attraction, the bonds, between the particles of the solid as it turns into a liquid. The process of melting requires extra energy, it is endothermic. When all of the solid has melted, then the temperature of the liquid will start to rise.